Hi and welcome to Chapter 6, Static Routing. Static routing helps us fix a path of communication between points in a network. Some advantages are that this path use is unknown and also not advertised over the network, so more security is given. However, the initial configuration and maintenance is time-consuming. This is because the static routing cannot learn any changes over the network, so it needs to be manually and constantly actualized. Static routing is used to summarize routing tables. Also, it gives the network the capacity to respond when there is a failure in communication between points. There are three types of static routing. The first type is default static route. The second, summary static route. The third is floating static route. Default static route helps the router have a gateway of last resort. This happens when the destination address of the packet cannot be resolved or doesn't match with the entries in the routing table. Some commands to configure IP static routing. IP route is followed by four parameters: network address or destination network address, subnet mask, IP address or exit interface. However, there are more parameters to this command. They are not relevant for this chapter. Depending on how the destination is specified, there are three types of routes. The first one, next hop route, only uses the IP address for the next hop. It doesn't care about the exit interface. The directly connect static route only cares about the exit interface and doesn't care about the IP address of the next hop. The fully specified static route uses the next hop IP address and the exit interface for the packet to be forwarded. To verify the static route, there are three commands: IP route, show IP route static, and show IP route network. To configure the next hop static route, we need the network address, the mask, and the next hop IP address. To configure directly connected static routes, we only give the exit interface at the end of the command. For the fully specified static routes, we give first the exit interface and next the next hop IP address. To configure default static route, we only give the IP address and the exit interface along with 0000 for the network address and 4 zeros for the subnet mask. Static routing is also supported in IPv6. Therefore, we need some similar parameters to configure. IPv6 prefix is also the destination network address. Prefix length gives us the subnet mask for IPv6 address. Also, we need the next hop IP address or IPv6 address and exit interface. Depending on the type of destination we configure, we also have next hop static IPv routes, directly connected static IPv6 routes, and fully specified static IPv6 routes. CDR or classless interdomain routing replaces the classful network assignments and address classes became obsolete. The network portion of the address is no longer determined by the class, but instead it is determined by the network prefix /8, /16, etc. It reduces the size of routing tables and manages the IPv4 address space more efficiently using route summarization. Supernetting occurs when the route summarization mask is a smaller value than the default traditional classful mask.
It is time to talk about the route summarization. It is the process of advertising a continuous set of addresses as a single address with a less specific and shorter subnet mask. The CIDR is a good example of a route summarization. This process reduces the number of entries in a routing updates, as well as the bandwidth utilization for routing updates. It also results in a faster routing table lookups. The conditions for row summarization are: the destination networks are contiguous, and they can be summarized into a single network address. All have to use the same exit interface or next hop IP address. There are 3 steps in order to summarize a network. The first step is to list the network in a binary format. The second step is to count the number of far left matching bits in order to determine the mask. The last step is to copy the matching bits and then add the 0 bits in order to determine the summarized network address. In this case, the summarized network is 172.20.0.0/14. The commands in order to accomplish the row summarization are the ones shown in the next picture. It is also possible to assign multiple static rows in an IPv6. Despite of it, this process takes 7 steps. The first one is to identify the part where the addresses differ. The second step is to expand the IPv6 if it is abbreviated. Step 3 is to convert the different section from hexadecimal to binary format. Step 4 is to count the number of far left matching bits in order to determine the prefix length for the summary route. Step 5 is to add the 0 bits in order to determine the summarized network address. Step 6 is to convert the binary section back to hexadecimal. And step 7 is to append the prefix of the summary route. The commands in order to accomplish the IPv6 row summarization are displayed in the next picture. It is time to talk about the floating static routes. These routes are static routes that have an administrative distance greater than the administrative distance of another static or dynamic route. Static routes have a default administrative distance of 1. These floating static routes also provide a backup to a primary link. The static route floats, and it is not used when the route with the better administrative distance is active. The commands in order to accomplish a floating static route are displayed in the next 2 pictures. It is also important to talk about the issues about the troubleshoot in the static and the floating routes. The networks are subject to processes that can cause their status to change quite often. An interface could fail, a service provider may drop a connection, the links could become oversaturated, or an administrator could enter a wrong configuration. If any of this happens, then the connectivity may be lost. Unfortunately, there are iOS troubleshooting commands in order to detect or identify a problem in order to solve it. The most common iOS troubleshooting commands are the ping, the trace route, the show IP route, the show IP interface brief, or the show CDP network detail. We have reached the end of the chapter 6 video, but remember to visit the NetAcad in order to read all the information of the chapter. It is all, and thank you for listening to us. Thanks.